Good morning, everyone. Welcome to our program, Aep Hp, where everybody deserves healthcare, even wind turbines. The main objective of Aep Hp is to be a powerful tool for the engineering team in wind farm facilities to monitor the condition of wind turbines and carry out diagnostics to detect issues early, and carry out preventive measures to avoid costly maintenance and to reduce overall downtime of wind farms. So when we were approaching this project, we first had to identify common problems that wind turbines face. We did our research and found out that debonding, gear failure, splitting along the fibers, and damage on the blades were common issues. Then we tried to look at indicators on how these problems could affect the operation of these turbines. At the end, for our plan, we decided to monitor sound, heat, and vibration profiles of the wind turbines. As with sound, we're able to detect loud noise and irregular patterns. With heat, we can identify overexertion of mechanical parts that could potentially lead to the failure of the gearbox. And with vibrations, we can visualize inconsistent patterns that could lead us to identify problems on the blades or internally within the gearbox. In Aep Hp, we are also implementing a heat index, which combines temperature and humidity data to reliably predict overheating. In addition, we are also ensuring real-time data delivery to ensure response to irregularities that can be done immediately. For our prototype, we'll be utilizing accelerometers, an acoustic sensor, temperature and humidity sensor, and Bluetooth modules to build our vibration and sound profiles, our heat index, and to ensure real-time data sharing. Here are photos of our prototype. On the left side, you can see there's our Bluetooth module and all our sensors are fixed onto the body of the table fan that we have here to simulate the functionality of a real turbine.
Combining all these sensors gives us data, and after modified, our team is able to convert them into multiple profiles, which help us better understand the situation of the wind turbines. So within these slides, the accelerometer's data is at the top, heat index is shown in the middle, and sound data is at the bottom. As the provided fan has 3 stages, we collected all of them to further study the patterns. As the graph shown, the faster the propeller spin, the larger the vibration is shown, and also the louder the noise is. Furthermore, the data could be used to form a database and be a reference when there's an abnormality happens. In the next slide, the graph shows the profile of a malfunctioning fan operating during low speed mode. We could see that the vibration and sound curve are inconsistent. Comparing with the graph that we captures when the fan is operating normally, it definitely has a huge difference. However, this is only caused by a small tie wire is attached on the propeller. This experiment is able to show that the system is a valid proof of concept. Aside from that, we will showcase the heat index part during the judging section tomorrow. Some of the future possibility includes carrying out emergency responses by the system itself, transferring the graph via Laplace transform, and applying machine learning. These steps are assisting us to translate our data into information and also reduce the damage of a malfunctioning wind turbine. Most importantly, the professionals could use the technology to further diagnose the issues, which eventually leads to shorter downtime. And that sums up our presentation, and we're really grateful for the opportunity.